Hello everyone. Did you know that modern cars use a variety of sensors like autonomous cars? You may think the two vehicles are entirely different, but they're actually quite similar. One example of a regular vehicle is the BMW 440i, which according to Buy BMW Parts Now, uses ultrasonic sensors and cameras to aid the driver when parking. Regular cars also use LiDAR and radar sensors. These same sensors are used on autonomous vehicles like Tesla or Waymo.
We'll be going over the main common physical components found in autonomous cars, and I have a representation with me to help you understand. So we have the LiDAR, and essentially what it does is that it spins 360 degrees and determines the distance between an object and the vehicle by analyzing light that it reflected. Next up, we have the radar, which is going to be in the front and back of the car. And essentially, it shoots out electromagnetic waves to determine a mutual velocity between an object and the vehicle. Next, we have the ultrasonic sensors, which help with collision detection and parking assistance and other features like that. Then we have the camera, which essentially takes pictures to create 3D images and detects traffic lights, traffic signs, and different and other road signs. Next up, we have the GPS, which is going to be right here. And essentially, it gives the location and time information to the car. Next up, we have the inertial measurement unit, which is going to be this right here. And essentially, it gives information about the vehicle's velocity, orientation, and gravitational forces. And then finally, we have the CPU, which will be in the trunk, and essentially combines all of that data from the rest of the vehicle and makes decisions and sends outputs to parts like automatic steering, throttle, and braking systems.
Hey, Vihan here. My part is how autonomous cars work without AI. Early autonomous systems use simple deterministic rules, basically small state machines that react to sensor inputs. Here's a really simple example. Let's say the car is in a cruise state. If the radar detects a car ahead of it, it moves into follow and matches that car's speed. That is until the distance becomes too small between them, in which case it brakes, until the distance is safe again. Now, if the road is clear and there's no more cars ahead of it, it can move back into cruise. Here's another example of a small autonomous go-kart using its own simple rules. As you can see, when the sensors see the road narrowing, it slows or turns. Same idea. No AI, just fixed reactions. This kind of rule-based logic works on simple, predictable roads. But real roads are messy. Construction zones, weird pedestrian behavior, missing lane lines. That's why modern autonomous cars rely on AI instead of just fixed rules.
Features present in these fully autonomous cars. First, we have perception and prediction. Perception models make use of its sensors, which include the radar, the video cameras, the LiDAR, which I think Asher has talked about in detail. But it uses these sensors to collect the data around it, whether that's a pedestrian walking or that's a car moving. It collects it and passes it to the central computer, which fuses all this information to label everything around it. Based on this, it uses behavioral modeling as well to understand dynamic ones and makes a good prediction. Then you have decision planning and algorithms. Based on its prediction, it plans out what to do next. It uses real-time decision planning algorithms. This includes steering, braking, acceleration, and then you have the actuation models, which actually execute all of these decisions. Then you have V2X, which stands for vehicle to everything. This basically is just vehicle communicating with everything around it, whether that's other cars, traffic signals, pedestrians, to keep refining its AI model and improving itself every single time. This makes the car situationally aware. And that's how these AI autonomous cars work.
So, how do we take those algorithms from theories to road? Let's look at Tesla's self-driving model. Instead of programming manual rules, Tesla uses machine learning and artificial intelligence. According to the Tesla 2024 AI report, they have over 6 million cars constantly recording videos, capturing billions of real-world driving data. They feed all the video into a Dojo supercomputer, which is a Tesla custom-built supercomputer designed to process video data faster than a normal computer. It trains a massive end-to-end neural network. In the past, engineers code specific rules, but now, with the help of AI, it takes raw video inputs and outputs, steering controls, and other rules to figure out itself. This means the AI is not just following checklists, it's using human behavior to drive and figure out how to handle complex situations like a construction zone or just by looking at pixels of the cameras.